So hello everyone. Today we will be starting a new module which is on mechanics. So the first learning outcome which is to understand the motion of objects in mathematical terms. So this unit it has more to do with mathematics and basic laws of physics, and then thereafter we will proceed further. So in this session, we will be covering explaining the relationships between displacement, velocity, and acceleration, and then drawing distance time graphs from measurements and extract and interpret lines and slopes of distance time graphs, and then discussing Newton's three laws of motion with examples. So these three things we will be covering for today's session. So first one is we will cover the relationship between displacement, velocity, and acceleration. So this is the main concept that will guide you to the mechanics and its use in later physics. So the first thing we need to be aware of the concept of distance and displacement. So distance is the total length of the path traveled by an object. So distance could be point 1 to point 2. It could be a straight line distance. It could be a circular, it could be a curved distance. So basically it is measured by how much length an object travels. So it is a scalar quantity because it only involves magnitude and doesn't take into account the direction. So basically a scalar is it takes into account only direction, and vector it takes into account both scalar as both direction as well as magnitude. So distance is a scalar quantity. So now displacement, on the other hand, it not only covers the overall distance, but also the direction of that movement. So displacement is a uh, vector quantity. So it has both magnitude as well as direction. So next we look into the concept of velocity and speed. So speed is the rate at which an object covers the distance. So it is a scalar quantity as it only deals with magnitude. So again, the concept of scalar and vector is also evident in terms of speed and velocity. So velocity is similar to speed, but again, it has magnitude as well as direction, whereas speed only has uh, uh, magnitude. So velocity, it refers to the rate at which an object changes its displacement over time. Since it has both magnitude and direction, velocity is a vector quantity. Now, here we look into the distinction between scalar and vector. Like I said, scalar, it has only magnitude, whereas a vector, it comprises of both magnitude as well as direction. So the distinction between vector and scalar, it lies in the treatment of direction. Vectors have both magnitude and direction, whereas scalars have only magnitude. So again, the example is between the distance and displacement, and the difference between speed and velocity. So this is one simple concept which you should remember when you're like studying general physics or you're studying engineering in general.
Can you repeat that?
Yeah. So the differentiation between vector and scalar, you should remember when you're studying physics or engineering in general.
Yeah.
Yeah.
Okay.
Yeah. So the next concept we look into is motion in a circle. So when an object it moves in a circle, its speed remains constant. That is, it covers the same distance in the same amount of time. So that is a circular motion, but its velocity changes because velocity considers both speed and direction. So if an object is moving in the same circle, it can have the same speed, say 25 kilometers per hour, but its velocity changes. For example, it will go east, it will go west, it will go south, it will go southwest. So that way you can measure the velocity, which is in terms of speed as well as the direction. For example, if you have to say, if a car is moving in a circular racetrack, so if you have to explain the speed of the car. So you can say it is moving at say 60 kilometers per hour. But if you're asked about its velocity, so you can say it is traveling at 60 kilometers per hour and it will be reaching say southwest in approximately so and so seconds. So that is how you differentiate between speed and velocity. So as the direction of the object changes while it moves in circle, its velocity is changing despite the constant speed. Why is velocity changing? Because its direction is changing.
Let me just write that down.
Sorry?
I just want to write that down.
Yeah, sure. You can write it down. Not a problem. And these sessions are also being recorded, so you can refer on to it later on as well.
Oh, okay, thank you.
So can I move ahead?
Yes, we can go forward.
Yeah, okay. So next is acceleration. So acceleration is the rate of change of velocity over time. So it is the second derivative of velocity. So when an object changes its speed, direction, or both, it is said to be accelerating. So acceleration is also a vector quantity because it involves both magnitude and direction. So again, the concept of vector, it comes for acceleration. So acceleration is calculated from the slope of a velocity time graph. So the time will be on the x-axis, the velocity will be on the y-axis. We will see in the upcoming slides. So a steeper slope indicates a higher acceleration. So examples of everyday accelerations. So for instance, a car accelerating from a standstill to a typical city speed might experience an acceleration of 2-3 meters per second square. And a person jumping might experience a temporary acceleration due to the force of their muscles. That is there. And then you have acceleration due to gravity, which is 9.8 meters per second square. So that is also the gravity. It pulls you down with an acceleration of 9.8 meters per second square. So acceleration, it can be negative. It can also be negative, representing deceleration or slowing down. For example, a car coming to a stop would experience a negative acceleration. So simple acceleration is when you speed up a car. And when a speeding car comes to a standstill, then it experiences a negative acceleration. So next we look into drawing of distance time graphs from measurements and extract and interpret lines and slopes of distance time graphs. So here you see the time variable is always on the x-axis. The x-axis is the bottom axis and the y-axis is the top axis, which is where you can see distance. So when any object is moving at a uniform speed, that means it covers equal distance in equal time. So for example, it covers 3 units of distance in 3 units of time. So that is how it is measured. But when an object is stationary, that means the distance will remain constant if you see the second phase, but the time will pass on. But when an object increases its speed, it has a very fast uniform speed. You will see it is a vertical line, so which is the third portion. And when it is a negative gradient which is returning to the start or it is decelerating, you can see as time passes the distance it comes down. It is returning to the starting point. So the graphs shown are distance time graph for various body motion. So like we explained, when a body is moving at uniform speed, which is the first part, Second one is when a body is steady or stationary. And the third one is when a body is moving non-uniformly with increased speed. The fourth one is when a body is moving non-uniformly with decreasing speed. So these are the outputs.
Yeah.
So the next one, we have a problem where the graph describes the journey of a man. So determine the speed of the man for each part of the journey. So this is a simple calculation. So here you see the time is from 10 to 15. That means for 5 hours. And the distance is from 0 to, actually it covers only till 15. So it can be 15 meters, 15 kilometers. So we will cover different aspects, which is A, B, and C. So the object covers from 0 to say 15 meters. Let us assume it is meters. Okay, it is kilometers. So 0 to 15 kilometers, it covers from 10 to 11:30. That means 1.5 hours. So from 10 to 11:30, the man traveled 15 kilometers from the starting point in 1.5 hours. So, sorry. So in this case, the speed is equal to distance by time. So total distance traveled is 15 kilometers. By total time taken is, it is 90 minutes. Or you can say 1.5 hours. So the speed is 10 kilometers per hour. For the next part, you see the distance is constant, but the time is elapsing, which means the speed is 0. Speed is equal to distance divided by time. So distance covered is 0 divided by time, which is 11:30 to 14:30. So anyway, 0 divided by anything, it will be 0. So the third option is C, where you see the distance covered is again 15 kilometers, and the time elapsed is 90 minutes, which is 1.5 hours. So again, speed is equal to distance traveled is 15 kilometers divided by time is 1 hour. Okay, so 13:30 to 14:30. So speed is 15 kilometers per hour. So this is how you can calculate using the graph. You can determine the speed of the person. So this one is clear for you?
Yeah.
So here we use the basic formula, which is speed is equal to distance by time. Okay. So next we move into discussing Newton's 3 laws of motions with example. So there are 3 fundamental laws of motion which is proposed by Newton. So the first law, it states that it is also known as law of inertia. So it states that an object at rest, it will stay at rest till an external and an object in motion will remain in motion unless an external force is acted upon it. So it is pretty common sense, but at that time, nobody proposed this general law. And this was not used in any concept, but this was proposed by Newton. So to state precisely, an object at rest, it will tend to stay at rest, and an object in motion, it will tend to stay in motion with the same speed and in the same direction unless acted upon by an external force. So, for example, if a book is resting on a table, it will remain stationary in that position, of course, unless an earthquake comes or something else comes. So earthquake is also a force on that. So a book resting on a table will remain stationary until an external force, like someone pushing it, is applied. So example 2, a ball rolling on a frictionless surface. So remember, the important term is frictionless surface where there is no friction. So if friction is there, the ball will come to rest due to the force of the friction, which acts against the rolling motion. So a ball
slow down.
Yes, it acts in the opposite direction.
Yeah.
So a ball rolling on a frictionless surface will continue to roll with a constant speed in a straight line unless an external force alters its motion. So if an external force increases its speed, so it will, the rolling speed will increase. If the external force acts in opposite direction, it will have a decrease. It will have an impact. It may fall down, or it will go in the reverse direction. But in both the cases, an external force is applied. So Newton's law of inertia, or the first law of motion, is obeyed in both the examples. So Newton's second law of motion. So this law states that the force acting on an object is equal to mass of the object multiplied by its acceleration. So you just have to remember Newton's second law is force is equal to mass into acceleration. So where F is force, M is mass, mass is the mass of the body, and A is the acceleration, which is velocity divided by time. So, first example is if you push a shopping cart with a greater force, it will accelerate more, which means it will increase its speed. And example two, in a car, when you're stepping on the gas pedal, which is you're applying force, it causes the car to accelerate, which is change speed according to its mass. So if you want a heavy truck to accelerate as quickly as a small car, you need to apply a greater force due to the truck's higher mass. So again, the mass plays an important role when you are studying the Newton's second law of motion. So the Newton's third law of motion. So for every action, there is an equal and opposite reaction. So when you sit on the chair, your body exerts a downward force on the chair. The chair simultaneously exerts an upward force on your body, which supports your weight. So even if you may not realize, there is the laws of physics which are working when you're you're doing your daily motions. So simple example is that when you sit on the chair, and in swimming, when you're pushing the water backward, with your arms, the force it propels you forward, which is the reaction. So that is Newton's third law of motion, action and reaction. So applying Newton's first law. So objects moving with uniform velocity experience no net force. An object in a car moving at a constant speed along a straight road will keep moving in the same direction and at the same speed unless acted upon by an external force. For example, if you place something like if you place something on your car seat, on your backside of your car seat. For example, if you place your handbag or something and you're going at a constant speed, there will be no change in its position. But if you apply brakes, the bag will come forward or it will drop. So that means that an external force is applied. So that is why when the car suddenly stops, you lurch forward, which means an external force is applied when you push the brakes. So that is how you apply Newton's first law of motion. Applying Newton's second law. So in everyday road transport, so Newton's second law is force equal to mass into acceleration. So in everyday road transport, when a car accelerates quickly, the force applied is proportional to the mass of the car and desired acceleration. So acceleration is provided by the engine. So this is why heavier vehicles require more force to achieve the same acceleration as lighter vehicles. So for example, if we see, if you are running, say, your sedan against a very high-powered, very heavy truck, so your car will achieve a faster acceleration, whereas the truck, it will take a very long time to achieve that type of acceleration. So that is because of the Newton's second law, which is force is equal to mass into acceleration. Even though the acceleration of both the vehicles will be the same, the mass of the truck, it forces it to, since it is larger, a larger force will be required to achieve that kind of movement, which your sedan will achieve. And then applying Newton's third law. So when a person stands still on the ground, they exert a downward force due to their weight. So you are applying a downward force. So how you are applying? Your body is equal to mass, whatever your mass into g, which is acceleration due to gravity, which is called weight. So your weight is a product of your mass and the acceleration due to gravity. So simultaneously, the ground exerts an equal and opposite force on you so that you are able to maintain the balance, and it leads to an equilibrium. Similarly, a book resting on a table, it experiences a downward force due to its weight, and the table exerts an upward force equal in magnitude and opposite in direction. So that is the concept of Newton's third law of motion. So that is all for today. In case if you have any questions, you can let me know.
Yes, no, I think I'm good.
Okay, then I'll see you next class day after tomorrow.
Yes.
Okay, thank you very much.
Thank you so much.
Thank you.
Excuse me.
Yeah, sure.
Hello?
Yes.
How will I find this recording?
This recording, it will get uploaded to cloud in about 30 minutes. After that, it will be uploaded in your LMS system by today evening or tomorrow morning. So I will forward it to the course coordinator today itself so that it is uploaded latest by tomorrow morning.
Okay, cool. Thank you so much.
Thank you.
Bye-bye.
Bye.